Yeah, so hi and welcome to 9.1, part 2. We're going to do a couple more inequalities, and then in the next couple sections we talk about compound inequalities, absolute value equations, and absolute value inequalities, but this is getting you back in that equation absolute value mindset. So just looking at this first one right here, we're going to do distribution, and recall that this negative right there acts like a negative 1. So our 19, when we distribute our negative 1, negative 2x, negative 1 here gives us minus 3 is less than or equal to. Distribute here, 2x, distribute there, plus 6, and then plus x. So once again here we're going to combine like terms. So we have our negative 2x's, 19 minus 3 is plus 16, is less than or equal to. X and 2x is 3x plus our 6. So now we need to get to the x's of the one side, so I'll subtract 3x. And because we're getting our x to the left, we need to get the number to the right, so subtracting 16. So we get negative 5x. 16's cancel, less than or equal to. 3's cancel, and then 6 minus 16 is negative 10. So here we're going to, let me just rewrite this back up here. We have negative 5x is less than or equal to negative 10. Divide by negative 5. Now we're dividing by a negative, so we want to flip the direction of the sign. X is greater than 2. So x is greater than or equal to 2. So getting this in set builder notation, line x, and we put the set brackets around that. If we wanted to graph this, because we have greater than or equal to, we want a solid dot. Because we're looking at x is greater than or equal to 2, our point of interest is 2, and because we're greater than it, we're going to be shading to the right. And then writing the interval for the solution set, it starts at 2 and includes 2, so we want to square and bracket, and it goes to infinity. So once again, here's the set builder notation, the graph, and the interval notation. All right there. So let's look at this next one here. Now, we could distribute this 4/5 in, but that's going to get messy. So we can always get rid of the fractions by multiplying through by the lowest common denominator. So between both sides, the common denominator is 5. So if I multiply this side by 5, as long as I multiply this side by 5, we're good. So here the 5's cancel, leave us 4 times 7x minus 6. Here we multiply, we get 200. So now we can distribute 4 times 7, we have 28x minus 24 is less than 200. Add some 24's. We get 28x. 24's cancel is less than 224. Then pick it up back over here. 28x is less than 224. Divide by 28. And then we can get a little bit of simplification here. That is, if nothing else on this side, the 28 cancels. So we have x is less than or equal to. Now, 224 divided by 28, it doesn't go in. Oh, it is 8. Oh, beautiful. It goes in exactly 8 times. So that works out perfectly for us. So x is less than 8. So putting this in set notation, line x set bracket. Graphing this. So the point of interest is at 8. We have an open circle because we're not including that. Because x is less than that, we're shading to the left. So the interval would be negative infinity to 8. So once again, the 3 different versions of the solution set. Set builder, graphic, and interval. Okay. So next two, we got a couple story problems. So we have this. Ava's taking an English course with 4 tests worth 100 points. Her scores are 94, 90, and 89. So these are her 3 scores. She asks, what must she earn on the 4th exam to get an A, so an average of greater than 90%. So we want the average of the 4 exam scores to be greater than 90. Okay, so one thing we do is this. It says, what must she earn on the 4th exam? So let x equal 4th exam score. And we want her average to be greater than or equal to 90. That is what this is saying right there. So if we're averaging 4 things together, we add them up and divide by 4. So the 4 exam scores are 94 plus 90 plus 89 plus x all over 4 has to be greater than or equal to 90. So once again, just like in the problem before, we want to get rid of the denominator. So I'm going to multiply both sides by 4. We get the cancellation here and here. And so I'm going to add these up and combine like terms. So 94 plus 90 plus 89 is 273. So writing this up here, we have 273 plus x has to be greater than or equal to 4 times 90 is 360. So subtract our 273 from both sides. So, and that is going to give us x is greater than or equal to an 87. So she must earn at least an 87% on that 4th exam in order to get an A for the class. Now, looking at this last one, we have this. Hudson Bank offers 2 checking plan. One costs 20 cents per check. Plan 2 costs 12 cents a check and $2 a month. How many checks must you write for plan 2 to cost less? So we have plan 1, plan 2. I mean, if nothing else, how many checks must we write to make plan 2 cost less? This is the inequality you come up with. The other thing is we're going to let x equal number of checks. Okay, so plan 1 is 20 cents a check, so you can say 0.20x. That's how much it's going to cost. Plan 2 is 12 cents a check, so 0.12x. And notice, this is in dollars and this is in dollars, and I'm doing that because we're adding $2 to this. So we want to make sure that we're all in the same type of currency. If we would put 20x over here, we would have been in cents, but I put 0.2, so we're in dollars. So now we're solving this inequality. This is the cost of plan 1. This is the cost of plan 2. We're trying to find what values of x will make that plan 2 less. So here we want to get the x on one side, so subtract 0.12x. So 0.08x is greater than 2. Divide by 0.08. And 2 divided by 0.08 is 25. So x is greater than 25. So you must write 25 checks for plan 2 to cost less. So hopefully that kind of jogged your memory on those inequalities, and we'll see you next time with some sets and some union to intersection stuff. Okay, bye-bye.